We've now seen 4 different techniques for solving quadratic equations. And in this video, we'll look at how to make the decision when given the opportunity to make the most efficient use of our time. What I've done is I've given us a priority list. What should we look for first, or second, or third, or fourth, if we're trying to make the job easiest on us and fast as possible? So for this first example, let's begin by checking out the first option. Can I use the square root property to solve this equation? Now remember, with the square root property, the idea is that we want the equation to say something squared equals a number, so that we can take the square root on both sides. So when I look at this equation, I want to ask, can I reasonably make it say something squared equals a number? Well, the parentheses are helping me to see something squared. So the question is, outside of that something squared, is everything else in the equation simply a number? And it looks like that's all we've got, is the something squared with a bunch of numbers around it. So what I'd want to do is I'd want to get the something squared by itself. Let's relocate all the other numbers to the other side. So first I'll relocate the 98. Since it's positive, I will subtract 98 from both sides. That leaves me with 2 times something squared, and it's going to equal a number on the other side. So now to get the something squared by itself, the only thing I have left to do is to detach this coefficient of 2. Since the 2 is attached with multiplication, I'll detach the 2 with division. Just make sure you do it on both sides to maintain the balance. And so now I have something squared equaling a number. Negative 98 divided by 2 gives me negative 49. And now I have something squared equaling a number. Now I can use the square root property. So let's square root both sides. Remember that the square root will undo the square. That's the whole point of using it. But as soon as the square disappears from that left side, be careful to remember that a plus or minus symbol will now appear on the right. The square root of negative 49, well, if I had just the square root of 49, I would say that's 7. The negative tells me this is imaginary, so I wind up with 7i. And last but not least, to get that x completely isolated, I do need to relocate this constant term. Since it's a minus 1, I will add 1 to both sides. I now have x by itself. On the right side, I'll put that relocated number first. I'll put the plus or minus last, so plus or minus 7i. Now be very careful. We want to know, can we reasonably combine these terms or not? Now this 1 is real, 7i is imaginary, so I cannot add or subtract these, so these terms are left separate. And here are my 2 solutions for x. X is going to equal 1 plus 7i, which is a complex number. Or x is going to equal 1 minus 7i, which is a different complex number. Those complex numbers are conjugates of each other. They have the opposite sign in the middle. So with this particular example, the square root property was going to be the most efficient, fast way to get through this problem. Now I could have completed the square, I could have done the quadratic formula, but if I was going to do that, I would have had to distribute all this stuff and move things around. It would have been a lot of extra work to even be able to start plugging and chugging, or to even be able to start completing the square. This one was just fast to go through with the square root property. Let's try another example and see how we can use this priority list to make a wise and efficient choice. So again, when we're asked to solve a quadratic equation and the directions don't dictate to us how to go about solving it, we do get to make the choice. But we want to make a wise choice, and we want to make sure our work is efficient. So again, we're going to use this priority list to make our decision and use the most efficient technique. The first technique we'll attempt is the square root property. Remember with the square root property that the first thing we need to see is something squared equals a number. Now in this particular example, I can identify the something squared. But beyond the something squared, I don't just have numbers. I also have an x term that's kind of in the way. So there's really no easy way for me to make this say something squared equals a number. So I'm going to say that the square root property is out for this example. The next most efficient possibility might be factoring. So let's give factoring a try. If we're going to try solving by factoring, we want to make sure that this equation is set to 0. So we're going to take this 6x, which is currently positive, and we're going to relocate it to the other side using subtraction. When we relocate it, we wind up with an x squared minus 6x plus 13 on the left side. On the right, we now have 0. Notice that when I relocated that 6x, I went ahead and put this trinomial in descending order because when I factor, I need to see that descending order anyway. So now if I were to try factoring this trinomial, I'd be using an X box to do so. And I would be looking for numbers which multiply to 13 and which add to negative 6. But I can't think of any pair of numbers that would do that, none that are nice anyway. And so it looks as though factoring is going to lead to a dead end. So I'm going to erase this since it led nowhere. And now I'm going to say that factoring is also out. So while square root property and factoring are both quick and efficient, like in this case, they don't always work. And so now we have the next two possibilities. And for both completing the square and the quadratic formula, both can be used for any quadratic equation. So I know I could use either technique here. But why I put completing the square as a first priority before the quadratic formula is I just want to see, is it possible to do completing the square without the nasty fractions? Again, on a test, you're going to have to demonstrate that you know how to use all these techniques. If you're going to need to complete the square at some point on the test, we need to make sure we're practicing it. Rather than practicing it when things get difficult, let's just practice when things are nice. So let's take a look at this example and determine whether it would be a nice example for completing the square or whether it would be terrible with fractions and we want to resort to the quadratic formula. If we were to complete the square, at some point we would need to add that magic number to create a perfect square. And the way we get that magic number is looking at the coefficient on x, cutting it in half, and squaring it. Sometimes cutting a number in half can create a fraction, but in this case, cutting negative 6 in half will just give me negative 3, which is a nice number. I think that I'm going to go ahead and complete the square on this problem just because I won't end up with fractions. This will be a nice opportunity to practice completing the square. So when I complete the square, the first thing I need to do is I need to make sure that there's nothing in front of my x squared term, that the leading coefficient is 1. And here I have that. So that's my go ahead to complete my first step, which is to leave my letters on the left and move my number or my constant to the right. Since 13 is currently positive, I will relocate it with subtraction. So the left side will have my letters x squared minus 6x. The right side now has my constant, my number, negative 13. So now that letters are on the left and the numbers on the right, this is the time for us to add that magic number that completes the square, the number that creates a perfect square on the left side. So I'm going to leave some space for my perfect number to get added in, and we'll do a little bit of thinking to figure out what that number is. To find that magic number, we look to the middle, we see that negative 6 coefficient on x. Our job is to cut it in half and square it. If I take negative 6 and cut it in half, I get negative 3. When I square that, which means multiply it by itself, negative 3 times negative 3 gives me positive 9. And so positive 9 is my magic number that I add to complete the square on the left. I also add it to the right to maintain the balance of this equation. So now we have a trinomial on the left, and you certainly could use an X box to factor that trinomial, but remember the shortcut. When we are completing the square, the whole point of adding the 9 is to create something squared on the left. And we have a shortcut for figuring out what goes in here. We'll use our variable, which in this case is x, but we look to the middle, we see negative 6, we cut it in half, and we will have negative 3 here. So we can cut straight to that if we can think of it. On the right side, these constants add up to negative 4. Negative 13 plus 9 gives me negative 4. And after this work, I now have something squared equals a number. And so I can square root both sides to remove the square. The square is now gone from the left. I have x minus 3. Remember that as soon as the square disappears from that left side, we do need to add the plus or minus symbol on the right. And then the square root of -4 is going to give me 2i. Remember that a negative under a square root is imaginary, so we'll need to see that I. Now to isolate the x, the only thing left to do is to relocate this 3. Since it's being subtracted currently, I will add to relocate it. Now x will be isolated on the left. On the right side, remember to put your relocated number first, so that's the +3. We'll put our plus or minus last, so here plus or minus 2i. And just verify at the end that these terms cannot combine. 3 is real, 2i is imaginary, so they will stay separated and not combine. Here are my two solutions, 3 plus 2i and 3 minus 2i. Now again, we could have solved this quadratic using the quadratic formula as well. Both the completing the square and the quadratic formula are able to be used at any given point in a quadratic equation. The reason I suggest using completing the square for this one is because it was nice. My nice magic number was a whole number. I didn't have to deal with fractions. And so if I need to practice all these techniques at some point anyway to prepare for the test, I would use completing the square as a choice when things turn out nice. If this were to give me a fraction for my magic number, I would just skip the completing the square altogether and go straight to the quadratic formula. Let's take a look at another example. So here's another example, and as we're looking through our list of priorities, the first priority to consider is, can we solve this using the square root property? Meaning, can I make the equation easily say something squared equals a number? Well, in this example, I don't even see a square symbol, so I don't see how I can quickly make it say something squared equals number, so the square root property is out. Let's consider factoring as our next possibility. Now, if I'm going to factor to solve, I want the equation to say something times something is 0. In this case, I do see some factorization happening. I see a something times something, but this is not a helpful factorization. This is not something times something is 0. There's stuff added, it's equaling 5. So those parentheses are just straight up not helping. Let's get rid of them. Let's distribute to loosen things up a bit. So we will have 7x plus x times x is x squared. X times -3 is -3x. And this is equal to 5. Next thing I see I can do is I can combine like terms. The 7x minus the 3x will combine. So I've got the x squared, and then 7x minus 3x is a +4x. So now again, if I'm trying to factor, I got rid of those parentheses because they weren't helpful. But before I start factoring, I want to make sure that this is set to 0. So that 5 needs to move. Right now the 5 is positive, so let's relocate him with subtraction. That leaves me with x squared plus 4x minus 5 on that left side, and it now is set to 0. When I set this to 0 and I play with this, I want to make sure that I'm getting this in descending order because I eventually need that anyway. But this is now loose, it's in descending order, it's set to 0, and now I'm allowed to try to factor. If I were to try factoring this, first I'd look at the order, which I already set up to be descending. Second, I would look for a GCF. I see that no GCF exists here except for 1, so I won't bother pulling it out. Next, I look at how many terms, and I see 3, so I'm going to do an X box. I'm going to do this over here so I have enough space. In the X box, I'm looking for a particular product and a particular sum. The product is always your first number times your last number, so here it's 1 times -5, which is -5. Your sum is always in the middle, which in this case is 4. So we're looking for numbers that multiply to -5 and add to 4. Those numbers are going to be 5 and -1. And because there was nothing in front of x squared, I can take those numbers and throw them right on into parentheses. So I'll have x plus 5, and I'll have x minus 1. Keep in mind this is still an equation and it needs to be all the way through. The last step said that this stuff equaled 0, so I'll keep that here. But now what I've done by setting it equal to 0 and factoring, I've created a situation where I'm saying something times something is 0. And based on the 0 factor property, I know that one of those factors must equal 0 if they multiply to 0. So either x plus 5 must equal 0 or x minus 1 must equal 0. One of them's got to be 0. Now, if I took these two linear equations and tried to solve them, my job would be to relocate the constant to the other side. So for the 5, I'd be subtracting. For this 1, I would be adding to relocate them. And this gives me two solutions for x. 0 minus 5 is negative 5. 0 plus 1 is 1. And I wind up with two solutions. We expect two solutions when we're solving a quadratic, and while I didn't see the square here when I distributed, I saw there was a square as my highest exponent. So again, this could have been dealt with completing the square, or I could have used the quadratic formula, but factoring wound up being the fastest, most efficient way through, and so that's what we ended up using. Let's take a look at one more example. So far we've done square root property. We have now factored. The last one we did was completing the square. I bet you can guess what we're going to do on the last one. But let's see how we come to that decision on our own. Okay, here we have our last example. Again, I'm going to go through this list of priority options. The first option is, can I reasonably use the square root property to solve this equation? Really what I'm asking is, do I see a clear path for making this say something squared equals a number? And when I look at this equation, I don't even see a square symbol. So I don't see a clear path to say something squared equals a number. So I'm just going to forget the square root property. I'm not going to bother. The next fastest option to consider would be factoring. Now I can't factor to solve unless everything that is already trapped in parentheses has been released and then this gets set equal to 0. So let's at least start there. Let's try removing these parentheses to release these terms. We will distribute. So 5x times x is 5x squared. 5x times negative 1 is negative 5x. And then I have minus 7. On the other side, 4x times x is 4x squared, and 4x times negative 2 is negative 8x. So at least now everything's free and loose to move around. What I'd like to do now, if I were to try factoring, I'd want to push everything to one side to set it equal to 0. So let's do that. Let's subtract this positive 4x squared from both sides to relocate it. While we're at it, let's also move that 8x. Since it was negative 8x, let's add 8x to both sides. Might as well multitask when we can. So all of this stuff will cancel out from the right, leaving us with 0 on one side. On the left, we have 5x squared minus 4x squared. That's just 1x squared. We have negative 5x plus 8x. That's plus 3x, and then we had the minus 7. This is now equal to 0 because 4x squared minus 4x squared cancels, and negative 8x plus 8x cancels. So now we have cleaned this equation up quite a bit. We've gotten rid of the parentheses, we've pushed everything to one side and combined all the like terms that we can. So now comes the question, can we factor this polynomial? If we were to try, it would be a trinomial, so we'd look at an x box, and we'd be looking for numbers which multiply to negative 7, and which add to 3. But when I consider all the pairs that are optional here, I don't see anything that's going to multiply to negative 7 and add to positive 3 at the same time, so it looks as though factoring is out. I can't factor. But all the work that I just did, it wasn't a waste. It wasn't a waste. Even though I can't factor, the next two places I go, I would have needed to get rid of parentheses anyway. So this was good work to do, even if I can't factor. So it's not a dead end yet. Not a dead end. Every quadratic equation can be solved one way or another. We just can't use these two efficient techniques. So let's now look at completing the square. If I'm going to complete the square, let's think ahead on this and decide if this is going to be a useful technique where I want to go through it or not. Again, every quadratic equation can be solved by completing the square, but sometimes it's messier than we want to deal with. The way we complete the square, when we're looking for that magic number to complete, we look in the middle, we cut that number in half and we square it. And if you just imagine taking 3 and cutting it in half, you're going to wind up with a fraction. So while you can complete the square to solve this, I would say if you've been given a choice, don't choose fractions. If you don't have to, don't choose it. If it's going to be messy, don't bother, because we have another technique that will work. Let's take a look at using the quadratic formula to solve this one. If I'm going to use the quadratic formula, I want to identify who A, B, and C are. In this case, A is 1. It's that invisible coefficient on x squared that I didn't see. B is the coefficient on x, which is 3 here. And C is the constant, which is -7 in this example. What I'll need to do is plug those into the formula, but I'm going to tell you what, if you ever use a formula in math, you'd better write it down, because otherwise the reader doesn't know where you're going with this. So first thing I'm going to do before I start plugging and chugging, I'm going to write the formula, the quadratic formula. So the formula is going to be -b plus or minus the square root of b squared minus 4ac all over 2a. And if you're looking for a tool to help you remember that, one option you could do is remember the story about a negative boy who couldn't decide whether or not to go to a rad party. And that boy ended up being a square, and he missed out on 4 awesome chicks. And the party was all over at 2 a.m. Whatever it takes to help you memorize it, do whatever you need to do. I would say that most of the time, just writing it every time you use it is enough to help you memorize it. But once we've got the formula, our job is to plug and chug. So let's plug things in. Remember, when you plug things in, use parentheses. So -b will be negative, and then 3 in parentheses. Plus or minus square root. B squared will be 3 in parentheses squared, minus 4, times A times C, in this case, is times 1 times -7. Now all this stuff was under a square root here, and this is all over 2 times A, which is 1. So we write the formula, we plug things in, now we take care of the multiplication. Negative times 3 is -3, plus or minus square root. 3 squared is really 3 times 3, which is 9. -4 times 1 is -4. -4 times -7 is positive 28. Downstairs, 2 times 1 is 2. Next thing we need to do is we need to clean up the radicand, so we need to actually add 9 plus 28. That will give us a radicand of 37. And then at this point, we would check to see, can I clean up that square root of 37? Is there a perfect square inside it that I can pull away? And in this case, there's not. 37 is prime, so we're going to leave the root. And the last thing I check is there a GCF on every single term that I can divide away from everyone? And in this case, the GCF is 1, so this is already simplified. Here's my final answer. Again, I could have solved this one using the completing the square technique, but it would have given me a lot of nasty fractions to get through the problem. So being able to fall back on that quadratic formula is nice. So again, as you're working through examples where the directions don't dictate how to solve it, and they give you the option and the freedom to choose, practice using this priority list, because it's going to help you actually practice each of the techniques when they're possible and when they're efficient. I don't want you to dwell on one technique that you like and then forget the others, because then when it comes to the test, you're not going to be able to remember all the techniques. So I would encourage you again to try using this priority list to go for the most efficient, the kindest, the easiest, the simplest way to get through solving these quadratic equations.